this video. Here we'll be learning how to solve quadratic functions and how to solve particular equations that look like a quadratic function. I've taken the liberty and I'm going to show you an example here. Believe it or not, this equation, as complicated as it may look like, this function, as complicated as it might look like, can be solved similarly to what we do with quadratic equations. By the end of the lesson, you will find out about the answer to this question. Alright, so let's first of all look at what's the domain and what's the range. Domain is all the x values that are fed into a function, and the range is all the output or the y values that come out of the function. So this mapping is x squared, so 3 is mapped to 9, 7 is mapped to 49, minus 7 is mapped to 49 as well, and so on and so forth. So we can draw a function, we can draw a graph for this function here, and it would be just simply a quadratic graph where you have a smiley face and it's symmetric around the origin here because we don't have an intercept, it's just x squared. Alright, as you notice, and you might already know, this graph must be symmetric around the y-axis because both negative and positive values of x map to the same value. Alright, so in this next two functions, f of x is 2x minus 10 and g of x is x squared minus 9. This notation here means that x can take any real value. That means that x can go from minus infinity to positive infinity and so on. So, and it includes 0 as well. So that's what it means. The capital R here means real values. Now, the first part of the question is saying figure out these values. F of 5, that means substitute x equals to 5 into this equation and evaluate it. 2 times 5 minus 10, and 10 will have to be substituted into this function here. So where x is, you substitute the 10. And part B is solving an equation. Let's just answer part A first. So we're substituting 5 for x. So 10 minus 10 will be 0, right? Okay, so that's the answer to that problem. Then we substitute 10 into g of x. 10 squared is 100. 100 minus 9 is 91. So that's the answer to that part. Then part B is saying equate 2x. What it is 2x minus 10, that's f of x, and set it equal to x squared minus 9 and solve this equation. So knowing how to solve quadratics, first of all we make this equation equal to 0. It makes more sense to leave x squared on the right and subtract 2x and add 10 to both sides. You end up with this expression here. Once you've done that, you'll get a quadratic that's equal to 0. Then you can factorize it and find the roots. It seems like minus 1 goes inside the bracket both times. Alright, so x equals to 1 is a repeated root. Why do we call it a repeated root? Because the graph touches or is tangent to x equals to 1 both from the left and from the right. So if you come across the word repeated root in chapter 4 when we draw the graph, that's what it means. In this next equation, we just have to complete the square in part A, and part B involves finding the root of that equation. And by completing the square, we would have helped us to answer part C, where it's looking to tell what's the minimum value of f of x. So let's start by completing the square. What's the first step to do? You take the positive value of 6x and divide it by 2 and put it inside the bracket where you apply the square. Alright, so half of 6 is 3. Then you have to subtract what? You have to subtract square of 3. And you combine that with the minus 5, so you'll have negative 14. All right. So this is the square root form. Sorry, this is the completed square root form, and this will tell us what's the minimum value of the turning point. Well, we're not really concerned with the with the x value. The x value of turning point is -3, but the y value is more important, which is -14. This is already the answer to part C. All right, so let's answer part B here. You're going to set this equation equal to 0 and solve it. Okay, so setting the equation equal to 0, we this is the completed square form that we completed on the previous slide. So once you've set it equal to 0, you take 14 to the other side and you take the square root of 14, which gives you plus and minus sign there. Then you end up with -3 plus or minus root of 14. So this is left in third form as the question asks us to do. So the roots of the equation are these two values. It might be helpful to write x1 and x2 separately. Alright, so to answer part C, we already noticed that the completed the square form at the lowest value of y at -14. So that's all you have to report, is that this turning point occurs when x equals to -3 and y value will take the lowest point to be -14. The fact that we used an inequality sign doesn't change the answer. The inequality sign is just saying that the square part will always be positive here. So when you take away 14 from something squared, you'll always be the lowest value it can be is -14 because we just subtracted 14 on both sides of this inequality. That's another way of thinking about what's happening here. Now, we also have an exercise where you will be translating this x square according to completed square form. I'll explain that in more detail in future videos and how the completed form is translating this graph into where the turning point goes to, for in this example, -3 and -14. The translation vector is written as -3 for x value and -14 as y value, like so. This is called a vector, and we'll see uh, more examples of this in the future. Alright, so let's look at these final two examples that may look rather complicated, but they're not. In this question, we've been told to find the roots of this kind of equation. Now, you have no idea, and I don't expect you to know what the graph for this looks like. But if you make a replacement of x to the power of 3 to be some other variable, let's call it capital X here. Let's call little x cube x to the power of 3. So this is can be written as x squared because 6 is 3 times 2, right? So where I have x to the power of 6, that's really capital X squared, squaring both sides of this. So, and then I write 7 times capital X minus 8. I can factorize this equation here. This equation has factors capital X inside the brackets at the beginning, and then I'll choose my positive 8 and minus 1. Positive 8 and minus 1 go inside the bracket. So that tells me that capital X equals to minus 8 and capital X equals to 1. Now, what was capital X? I go back to my original substitution. I write that as x cubed here and little x cubed here. Now, what value of what is this solution to this equation here and this equation? This tells us that x here is cube root of minus 8. Yes, you can take a cube root of a negative value because negatives do have cube roots. So that's a minus 2. And the other answer, cube root of 1, is still 1. So that's the final answer to this problem. Now, you do have a more complicated example. Uh, Let me rewrite this as so. So, now there are two ways to solving this problem. If you don't like my substitution, this is just what you would have done. Now, in this next question, if you think carefully, you can rewrite this 2x as x times 2. Why do I do that? Because I'm going to use a different letter, let's call it z, and say 4 to the power of x is going to be z. Therefore, where I have 4 to the power of 2x, I can write it as 4 to the power of x in a bracket squared. This is 4 to the power of 2x. 2. So that is simply z squared, right? So I can rewrite g of x as z squared plus 12z. This is a 12, and this is z. Let me put a line here. And plus 27. Now, what if I had to factorize this? What are the factors of this equation? It's plus, plus. Have you guessed it? Yes, it's plus 3 and plus 9 here, because they add up to 12 and multiply to 27. So that means that z equals to actually a minus 3 and z equals to a minus 9. Now, I didn't choose a good values for this equation because when I was making it up, because no values of x actually will give us these answers. So perhaps the question would have been better written as uh, a minus 12. Alright, so the takeaway from this question was that every time you see the powers of x uh, in this ratio of 2 to 1, where 6 is twice as big as this 3, no matter what these were, the ratio is important. So even if I had a x to the power of, say, 60, and I had x to the power of 30, I would have used the same sort of logic here. It could be divided into quadratic, where I would set x to the power of 30 to be, well, small x to the power of 30 to be capital X. So x to the power of 60 would be capital X squared. So I would have used the substitution, and I would have solved it in similar fashion. So in this next example here, we're going to take a letter. I'm going to choose Z and set 4x to be Z. So where I have 4 to the power of 2x, I can write that as Z squared, because what I'm doing is saying 4 to the power of 2x can be written as x times 2, and I'm choosing to put a 2 outside of the bracket here. Alright, this is just writing 2x in a different way. So then I can use this substitution to rewrite this as z squared minus 12z plus 27. Now, factors of positive 27 that add up to minus 12 are, have you guessed it, minus 3 and minus 9. So I'm going to write z minus 3 and z minus 9 inside the bracket. When I take them out of the bracket and solve them, I get these answers here. Now, going back to my substitution, I have 4 raised to the power of x to be 9 and 4 raised to the power of another x to be 3. Now, when you learn about logarithms, you figure out how to solve this equation fully, but at this case, I'm just going to tell you that you could leave it in this form, that would be fine. All right, so I'll see you in the next chapter. I hope you have good practice with this kind of situations.